Okay, today we're going to talk about inverse trig. And in inverse trig, there are some very important things. There's a lot of stuff on this very first slide. I'm not really going to talk about any of it. You can read it later. Let's move to the second slide. In inverse, you will see two kinds of notation that indicate that you're dealing with an inverse function. For example, you might see y equals arc sine x. This arc stuff means that you have an inverse function. You may also see it written as y equals sine and a little raised minus 1 x. This raised minus 1 is indicating that you have an inverse function. If you look on your calculator, you will see it written the blue way. But I want you to know that you may see in your notes and in your homework on the exam either one, arc or with a little minus 1. It doesn't mean to the negative 1 power. It means that it's an inverse, just so you know. If we look at the sine function that we've been talking about for a while here, we know that the normal period for the sine function goes to 2 pi. And if I were to graph that with its normal amplitude, what I would see is the following. I would see a graph that has one mountain and one valley between 0 and 2 pi. And remember, this is periodic or cyclical, so it goes on forever. So like I could continue and there'd be another valley starting there, so on and so forth. In inverses, because of the vertical line test that we do to talk about functions, we have to do something called restricting the domain. If you restrict the domain, what that means is that I'm only going to look at certain parts of the graph. The part in the sine that you look at is the part between negative pi over 2 and pi over 2, which is indicated up above here in the words. That your angles will go between negative pi over 2 and pi over 2. So recall, you might want to write this down again, most important thing about inverse functions is switch the x and the y. X is the domain, y is the range. So in sine, cosine, tangent, if I switch domains and ranges, that means whatever my domain was, the x values, for sine, cosine, tangent, those now become my ranges for my inverse functions of sine, cosine, and tangent. Inverse sine, inverse cosine, inverse tangent. And you'll see that indicated down below in this box where you see the word range. That those ranges were actually the domains of my functions. So now if I want to draw the arc sine, instead of going between negative pi over 2 to pi over 2 in the highlighted graph, my domain will go from 1 and 1 is not correct. 1 and negative 1 is correct. So now I'm going to draw a new graph, and my domain will go between negative 1 and 1. Because that was the range on my sine, it now becomes the domain on my arc sine. The range for my arc sine is whatever the domain was for my sine. So that went between negative pi over 2 to pi over 2. What am I doing? I'm switching the x's and the y's. I'm switching the x's and the y's. For me, one of the things that I do is if you look at the highlighted section of the sine graph, instead of writing right now, you'll notice that I have 3 dots. I'm going to take those 3 dots and I'm going to plot them on the new graph. The way that I'm going to do that is I'm going to look at the farthest left one. Look at the coordinates. Negative pi over 2, negative 1. You guys see that first dot? Instead of writing it that way, I'm now going to flip them, right? Switch the x and the y. So now instead of going negative pi over 2, negative 1, I'm going to go negative 1, negative pi over 2. Negative 1, negative pi over 2, and put a dot. Remember, most important thing about inverses, switch the x and the y. If I look at the middle dot, at the origin, you can't really do anything. 0, 0 still 0, 0. And then the last dot was pi over 2, 1, so now I go 1, pi over 2. And then I have to draw this thing. Remember, one of the cool things about inverses is that they're mirrored over the line y equals x. So I'm going to think about this as, oh man, I have some kind of a mirror right here. And I'm going to flip it so I can see it the other way. So that when I graph the arc sine, I get the curves in the correct direction. So my curve looks like this. And that is the only way to draw the arc sine. If your curves are incorrect, your graph is incorrect. In these next two, in order to draw the arc cosine and the arc sine, I'm going to actually draw the originals first and then go from there. So underneath the arc cosine, I'm just going to quickly draw the cosine graph. Oops. So just to recall, that the cosine graph looks like the following. Started up at 1, went down to the midline, came down to negative 1, up to the midline, and then up to positive 1. And this is our cosine graph. Remember, these are curves. There shouldn't be any straight lines, no V stuff in here. If you draw them crappy, you'll get marked off for your bad drawing. And I'm going to, just like I did with the sine, I'm going to extend this one just a little bit just to see it. If you look up in the table, the arc cosine has a different domain that needs to be restricted in the original function so that its range is correct in the inverse function. And so looking at my table, it tells me that the cosine is going to be restricted between 0 and pi. So what that means is I'm only looking at the values, bless you, between 0 and pi. Notice again how I have 3 dots on that graph. And in that situation, I was talking about a domain that went from 0 to pi. So now in my arc cosine, that's what my range is going to do. I'm going to go from 0 to pi. Was my domain, now it's my range. On the other hand, my range went from negative 1 to 1 in my original, so now that's my domain. So I'm going to go from negative 1 to 1. If I look at my coordinates from the original graph, the farthest left point was 0, 1. So now I switch that around and I'm at 1, 0. My second point was at pi over 2, 0. So now I'm at 0, pi over 2. And my last point was at pi, negative 1. And now I'm at negative 1, pi. So those are my 3 dots. Kind of looks like they're in a straight line, but they are not. If you flip the yellow over that line y equals x, you would see something that looks like this. And for some of us, visually, that might be a little bit challenging. So maybe sometimes it might be better just to memorize. Okay, the next one, same kind of deal. I'm going to draw the tangent first because I think that's very helpful. When you look at the tangent, you might recall that the period there was pi, which meant that I went from negative pi over 2 to pi over 2. And that the graph of the tangent looked like this. And there were asymptotes at pi over 2 and negative pi over 2. Since in the tangent, my domain went from negative pi over 2 to pi over 2, that is now going to be my range. So negative pi over 2 to pi over 2. And of course, that means I'm going to have asymptotes there, just like I did before. And the only point that's on this graph, which is unfortunate maybe, is that 0, 0 point. So I'm going to put that 0, 0 point here, so at least I have 1 point correct. And then kind of the way I think about drawing the inverse for this one is I look at where I went. So for example, let's look to the right side of this tangent graph. As I move farther and farther, or in other words, closer and closer towards pi over 2, what's happening to my graph? Going closer to infinity, just like Buzz Lightyear. So the coordinates, if you were to go on forever, over here on the right-hand arrow, would be going to pi over 2 for the domain and infinity for the range. Does that make sense? As I move closer and closer to pi over 2, I'm going up to infinity. If I flip-flop that, that means as I go towards positive infinity, I'm getting closer and closer to pi over 2. That means I'm going here, in this direction. Which means, of course, as I look at the bottom part on the left side of the original graph in red, as I get closer and closer to negative pi over 2, I'm getting closer and closer to negative infinity. So that's a graph in the orange of the arctangent or inverse tangent. Hopefully you're listening because I'm going to talk quieter now. So whenever you see things like inverse or arc sine, that means